Ma'am, you have to share the entire screen, ma'am, because something is hiding.
Oh, shall I stop and then share?
Yeah, now, yeah, okay. Go ahead, ma'am.
Now is it visible, sir?
Yes, ma'am. Yes.
Okay. Okay, good afternoon, students. Today we will see about the different types of delays that happens in a computer network. You have already studied about two types of switching techniques, circuit switching and packet switching. And in packet switching, as you already know, the application layer data gets divided into smaller chunks of pieces and it gets transmitted. So if you have topology that looks something like this. If, for example, you have a source and you have a destination. Between the source and the destination, there could be many intermediate devices, say like, let's assume there are 3 routers on the path from the source to the destination. Okay. So now in all this links and on the intermediate devices, different types of delay occurs. Now, what do you mean by delay? The time it takes to place the packets onto the medium, the time it takes for the packet to travel in the medium and then gets processed in the intermediate device, then again place them on the next hop towards that link. Then again, so in at every intermediate devices, processing happens and it has to travel certain distances before it can reach the destination. Traveling, that delay that occurs, we call it as, otherwise called as latency. Now you would have done in your lab classes to see this time. How much time did it take to reach certain destinations? I hope you remember when you use the ping command and the traceroute command, you would have seen this delay, right? You would have seen the round trip time. What do you mean by round trip time? The time it takes for a packet to originate from the source, go all the way till the destination, and then the reply to come back. Okay. Now there are 4 major types of delays that happens in the network while it is traveling, when the packets are traveling. The first type of delay is called as the transmission delay. So what does this transmission delay represent is when, for example, you have a source and this source is generating a packet of size, say, L bits. Okay. Now, all these L bits have to be placed onto the medium. Okay. So let's take this L represents, say, 100 bits. Okay. So bit by bit, the data is getting generated by the application that's running on the system. And all these L bits, 100 bits, or it could be 1000 bits, or even more. Okay, so whatever might be the size of the packet, the entire packet have to be placed onto the medium. Okay, so that time is called as the transmission delay. So bigger the packet size, the more time it takes to keep it onto the medium. Okay, so smaller packets, quicker it can be placed. So this transmission delay depends on 2 parameters. One is the size of the packet, and the second one is the transmission rate of the medium, or otherwise we call it as bandwidth. Okay, so it depends on 2 important parameters. Okay, so it depends on the link's capacity, which is the bandwidth, and the size of the packet. Lesser the bandwidth of the link, more time it takes to keep the packet bits onto the medium. Okay, so you remember the formula to calculate the transmission delay is L by R. Okay, so depending on how big the packet is and the transmission rate of the medium is, that transmission delay is computed. Okay, so the formula for calculating the transmission delay is L by R, where L represents the packet size and R represents the bandwidth of the link, which is nothing but the capacity of the link. That is how many bits can be sent per second. Okay, so normally when we tell 1 kbps link or 1 mbps link, what does that mean? 1,000 bits can be placed in the medium. That's a meaning in 1 second. Okay, so 1,000 bits of data can be kept in 1 second. That's a meaning. Suppose if I say 1 KB of data. If I say 1 KB of data, what does that mean? It actually represents 1,024 bits of data. Okay, so it represents 1,024 bits. So you have to remember, when we talk about data, it is in powers of 2. Okay, it is in powers of 2. Okay, so which is nothing but 2 power 10. Okay, so when we say 1 KB, it means 1,024 bits. Okay, whereas when we say bandwidth, it 1K means it is equivalent to 1,000. Okay, so these are two important points you have to remember while you're solving the problems. When I say data, it represents 1,024. 1K represents 1,024. When I say bandwidth, it represents 1,000. Okay, so which is nothing but 10 power 3. Got it? Now this bandwidth is it's linked with the frequency, so it is always represented in terms of decimal number. So it is 10 power 3, whereas in this data, when we say it is 2 power 10. Okay. Now the next type of delay that happens in the network is the propagation delay. Propagation delay represents how much time does it take for a packet to travel in the medium. Okay, how much time does it take for a packet to travel in the medium? Suppose if you have a router here, how much time after the entire bits of the packets are placed in the medium, they have to travel in the medium. So the longer the distance, the more time it is going to take to reach the next hop device. Okay? So shorter the distance, faster it can reach. Longer the distance, more time it will take. So till it reaches the destination, it might have to cross several routers or switches on the way. So at every link, this propagation delay have to be computed. Okay. So now this propagation delay depends on two important factors. What are they? The distance, how much it has to travel, and also the speed of the link. Okay, which is nothing but the bandwidth of the link. Better the bandwidth, the faster the bits are going to travel in the medium. Okay, so these are the two important points you should remember. So for calculating the propagation delay, the formula is distance by speed. Okay, so distance represents the medium's length, and speed represents the bandwidth of the link. Now, normally for the copper cables, the speed of the light is taken as the speed. Okay, so the I hope you know the speed of light value. It is 3 into 10 power 8 meters per second. Okay, so this is the value for the speed of light. Now, now this is used for the copper cable. Now, if you use the fiber cable, then we can get the speed of 70% of the speed of light. Okay, so therefore you have to multiply this speed of light into 0.7. 70% of the speed only we will get in the fiber cable. Therefore, the value is going to be 2.1 into 10 power 8 meters per second. Okay, so so you have to remember the units when you are solving the problems, because the delay is the time we are calculating. So when you represent time, you have to mention with appropriate units. Okay, so these 2 points you remember. When we use copper cable, the speed of light is taken to be the medium speed, which is 3 into 10 power 8 meters per second. And if it's going to be fiber cable, it is 70% of the speed of light. So you multiply by 0.7, you'll get 2.1 into 10 power 8 meters per second. Now, the next type of delay is called as the queuing delay. Now, when does packets have to wait before it is getting transmitted? Only if some packets are already have arrived early and it is waiting to get processed, they'll wait. right? So if, say, for example, let's take the packet have reached this router, and let's assume it is also processed, and let's take it is going to go out of this outgoing link. So let's take it is arriving through the fast Ethernet FA0/0, and it is going to be sent through the FA1/0 interface. Now, when it is going to be sent out, let's assume there is already some packets in the medium being sent. Okay, so in that case, the packets which are already processed, they have to wait in the queue here. So here they'll be waiting to get onto the medium. So the waiting time is called as the queuing delay. Suppose if the packets have arrived within this L/R time, right? If the packets have arrived within this L/R, all the packets would have already traveled. But if more packets or bigger packet sizes are coming, then beyond the link's capacity, the packets cannot be pushed. Therefore, they will be waiting in the queue, and there will be a buffer. Okay, so there is a buffer where all these packets are kept, and one by one they are sent through the appropriate outgoing link. So queues can happen while they are entering in or when they are leaving the router. Okay, so when entering in, when how the queue happens is if more packets are being sent from the sender. So let's assume the sender is sending, let's take 5 packets, and without any queues, the packets are flowing, let's assume. Instead of generating 5 packets, if this source is sending, generating, say, 500 packets or 5,000 packets, then definitely this router will not be able to process it. Okay. Again, it depends on the capacity of the processing speed of the router. Okay, so in that case, if more packets arrive, queue can occur and packets have to wait. So queuing delay is the time spent by the data packet waiting in the queue before it is taken for execution. So queue can occur while it is entering inside the router, it can happen, or when it is leaving the device also, queue can occur. Okay, so in that time, when they are waiting, that time is called as the queuing delay. Now, when the process is there in the routers, they are waiting process. Now, that is called as the processing delay. Now, what do you mean by processing delay? The time taken by the processor to process the packet. Now, what do you mean by process the packet? It has to examine the headers. Now, we have learned in the TCP IP layers how in each layer headers are encapsulated. So, during the encapsulation process, the headers are added. So, these headers have to be examined to look at the destination address, and based on the destination address, decision is made how to forward the packet. So, and also bit level errors are identified by the routers. So if any packets arrive with errors, then those packets will not be forwarded. Okay, so bit level errors are also identified by this routers. So when these routers examine these packets, it takes some milliseconds. Okay, few tens of milliseconds. So if that time is called as the processing delay. Now this depends on what this processing will depends on the speed of the processor. Okay, it depends on the speed of the processor, how fast it can process the packet. Okay, so these are the 4 types of delays, and with this we'll see how we can solve the problem. So 2 formulas you have to remember. One is for transmission delay, the formula is L/R. For propagation delay, the formula is D/S. For queuing delay and processing delay, there is no formula because it purely depends on the current traffic in the medium. So traffic can arrive periodically, it can arrive. In some cases, sometimes randomly, some packets can arrive. Sometimes it could be a bursty traffic where within few seconds, thousands of bytes of data is coming and then the system remains idle. So we cannot predict how the traffic arrival rate is going to be. Okay, so depending on the arrival rate of the packet, the queuing delay will vary at every node. So if you have many nodes along the way to the destination, at every node the queuing delay will vary. Okay, and then the processing delay depends on the processing capacity of the each nodes which are present along the path to the destination. Now, now this is what I explained. So you have the transmission delay. How much time does it take to place the all the bits of the packet onto the medium? Propagation delay is the time taken to travel from this point till this point. That means the last bit of the packet, when it reaches the second node, till then what is the time? Okay, so longer this distance, more time it will take. Shorter the distance, less time. And then the time it's spent inside the router, right? While the packets are getting examined. So within this, how much time is spent while it is entering? They might be queued. If more packets are arriving, then queue can happen here. While leaving also, if already many packets are on the medium, here the packets get queued. So queue can, because of waiting in the queue, queuing delay increases. Okay, so now when we sum up all these 4 types of delay, we get the end-to-end delay. So what is the total delay? It is the sum of all the 4 types of delay: processing delay, queuing delay, transmission delay, and propagation delay. Now, all these delays, typically it should be less than milliseconds. Okay, so when the delay increases, then we know that the performance of the network is not good. So this is one of the parameters for measuring how the network is performing. Now, if there is too much congestion in the medium, then queuing delay will increase. So as the queuing delay increases, the end-to-end delay is also going to increase, and therefore that shows that the network performance is not good. Now, what do you mean by traffic intensity? Now, traffic intensity is which shows the how fast the packets are being sent from the sender, or how fast the packets are arriving. So if the packets are arriving less than L/R, that means the packets will reach the destination quickly. That's a meaning. So, but when the more packets or the bigger packets are, say for example, we say that the links bandwidth is say R, and we say the packet of size L is arriving. Okay, so the transmission delay, that is transmission delay is how much? It is L/R. Okay, so let's take if there are 5 packets sent. The first packet will not experience any delay, right? So the first packet, because nobody is there already prior to the first packet, so the first packet will travel in the medium without any delay. And the second also will travel, provided if it is within this L/R. Okay, so that means if we say that L is say 100 KB, and if we send only 50 KB, definitely it will go in the medium. Okay, but if a bigger size packets are sent, then what happens? If a bigger size packet comes, we can see that the traffic delay, queuing delay slightly increases. For the first packet, there won't be any delay. For the second packet, there will be a slight delay. Then for the next one, it will little more, and so on. So it keeps on going. But when the arrival of the packets is fast, okay, packets are arriving fast and also coming in bigger sizes, then what happens is the queuing delay increases, because they all are getting queued, because we cannot send in this medium beyond this transmission rate of R, right? So with this R only we can send. Beyond that, they all have to queue. Therefore, queuing delay increases. So the formula for traffic intensity is LA by R. What is L? It is the packet size, R is the transmission rate, and A represents the average arrival rate of the packet. Okay, how many packets are arriving per second? Okay, so the more packets arrive beyond the capacity of the link, definitely they will have to wait in the queue before they get processed, and therefore the queuing delay increases. So if this LEA by R, that is the traffic intensity, reaches the value of 1. Okay, so here it is 0. When it reaches the value of 1, what happens? The queuing delay almost increases, and you can see a steep rise, and you can see that it keeps increasing. So what does this means? When the packet's arrival rate is beyond the maximum capacity of the link, and it is arriving at a faster rate, the packets are getting queued, and at some point, the packets which are waiting in the queue, when this buffer becomes full, what will happen? The packets will get dropped. Okay, when the packets get dropped, what happens? It has to be retransmitted, and this retransmission also will create additional traffic. Okay, so that's why based on the links medium, only the packets have to be sent. Okay, so here you can, to illustrate this, you can see a diagram here on the right side where you see an empty road here. When there is only one vehicle, it can go at the maximum speed, right? On the same road, same medium, but when there are too many cars, even if they have the capacity to drive faster, they cannot move because already more vehicles are before them. The same applies for the network also. When too many packets are arriving beyond the maximum capacity of the medium, then the packets have to wait. When they are waiting in the queue, that contributes to the queuing delay. And when they wait for an infinite time, what happens? The buffer becomes full and packet gets dropped. As a result, the packets have to be retransmitted. Okay. So this queuing delay shows that there is a severe problem in the network, and that has to be fixed. So to fix this, what can be done? You send the packet at a lesser rate. Okay. So the source have to be restricted from sending too many packets. Now we'll solve some problems using these 4 types of delays. So all of you, please take a note. We are going to solve some problems. Now you can take an example of a caravan. Let's assume there is 2 toll booths. Now this toll booth is equivalent to 2 routers. You can imagine that this is a router, and you have to cross this router to reach a destination somewhere here. And let's take, there is a source. Okay, so there is they are originating from this place. From the source, let's assume 10 cars are coming. So 10 cars is equivalent to how many packets? 10 packets. Okay, so let's assume each car is 1 packet. Okay, so 10 cars are arriving. At what speed are they arriving? They are arriving at a speed of 100 kilometers per hour. Okay, so they are arriving at a speed of 100 kilometers per hour. And these cars, when they enter the toll booth, they have to be processed. Okay, so here, what type of delay happens here? So this time taken to service this car is given as 12 seconds. So the problem, it is given as 12 seconds it takes to service a car, which is equivalent to what type of delay? What type of delay? Can you respond in the chat box? What type of delay is this? This 12 seconds of servicing the car? What type of delay is this? You have learned 4 types of delay. Which type of delay do you think is this 12-second represents? Okay, I can see different answers. Okay, most of you have given processing delay and queuing delay. Okay, so now the servicing the car represents the processing delay. Good, some of you have told the answer correctly. So the servicing the car represents the processing delay. So here it takes 12 seconds for processing the car. So in other words, to process the packet, to examine the packet headers and to check whether any errors are there in the packet, it takes 12 seconds. So if all these cars have to cross this toll booth and enter into the medium, okay, so here transmission delay happens. But in the problem is there any information regarding the transmission delay? How much time does it take? No informations are given. Okay, so we'll assume that the transmission delay is negligible. Okay, so let's take the transmission delay is 0 because nothing about that is given. Okay, so it's very negligible, therefore we ignore it. And the processing delay is given. So processing delay is given as 12 seconds. So to service this 12 cars, how much time does it take? For one car, processing delay is 12. So for 10 cars, it is going to be, can I see the answers in the chat box? So to service the 10 cars, how many time does it take? One car, 12 seconds. So for 10 cars, it is, students give the answers. Yes, it is 120 seconds. Okay, so it is 120 seconds. Can you tell me in minutes how much is this? 120 seconds is how many minutes? Very good. It is 2 minutes. Okay, so the processing delay is 2 minutes to cross the toll booth. Okay, okay. Now the question is, how long until the caravan is lined up before the second toll booth? So we want all the cars to come in front of the second toll booth. Okay, so that means all the 10 cars have to travel in this medium or in this road. Okay, so what type of delay is this? If it has to travel in the medium, what type of delay is that? We have studied 4 types of delay. Which delay is that if it has to travel in the medium? Very good. Okay, others? I see only one answer. We have assumed that the transmission delay is negligible. When it is traveling in the medium, that represents the propagation delay. Okay, so propagation delay, what's the formula for propagation delay? It depends on 2 things. What are they? Distance and speed. Okay, so what's the formula? D by S. Now, can you substitute the values and tell me what is going to be the time? What is the distance? The cars have to travel 100 kilometers. Or at what speed these cars are arriving? In 100 kilometers per hour. So what is the time? It is 1 hour. So if I convert this 1 hour to minutes, how many minutes is it? 60 minutes. So what is the total delay now? What is the total delay? Is there any queuing delay in this problem? Any information is given regarding queuing? No, right? So therefore, the total delay is equal to sum of all the 4 delays. So in this case, we have 2 minutes of processing delay and 60 minutes of propagation delay, which gives 62 minutes. Okay, we get a value of 62 minutes. So always when you represent time, you have to give the proper unit. You should not forget. Clear? Does anybody have any doubt in this problem? So we'll proceed. So now I'm going to slightly change the same question a little bit. Okay. So now you can solve this question. the same caravan problem. Suppose if the distance is 150 kilometers, beginning in the first toll booth and passing through the second toll booth and finishing just after the third toll booth. So can you calculate now? Now we have 3 toll booths. The problem is slightly changed with the distance. The rest all is same. Okay. So now they are starting this first toll booth. The same 12 seconds for the processing. It has to, all the cars have to cross all the 3 toll booths and the distance is changed. Now calculate and tell me. So what's the formula? Total delay is equal to propagation delay plus queuing delay plus transmission delay plus processing delay. Okay. There is no information on queuing and transmission, so we can take it as to be 0. Processing delay for one toll booth is 12 seconds. Okay, processing delay is 12 seconds for one car. So for 10 cars, we have already calculated to be 120 seconds. Now the question is, it has to cross all the 3 toll booths. So what will be the total processing delay if it has to cross all the 3 toll booths? This we got to be 2 minutes, right? So now it has to cross 3. So can you tell the answer? If it has to cross, yes, John Wesley has given right answer. So to cross all the 3 toll booths, the processing delay is going to be 2 plus 2 plus 2, which is going to be 6 minutes. Very good. Now calculate the propagation delay. Propagation delay. So now we have got 6 minutes for the processing. Propagation delay, calculate. What's the formula? D by S. So what is the distance? I have changed the question. Earlier we had 100 kilometers. Now here it has to travel 150 kilometers. So 150 kilometers. And at what speed it is coming? No change in the speed. Same 100 kilometers per hour. So what's the value? It is 1 point. Can I get the answer? Yes, 90 minutes. Okay. We get 90 minutes or 1 hour, 30 minutes. 90 minutes. Now, if all the cars have to line up after the third toll booth, how many links has it to cross? If all the cars have to reach cross the third toll booth, how many links has it should cross? To travel this much distance, it is taking 90 minutes. If all the cars which are lined up here have to come this side, how many links it has to cross? 2 links, right? So here also it takes 90 minutes. So, so 2 into 90 minutes. So can you tell me the final answer? Yes, 180 minutes of propagation delay plus 6 minutes of processing delay, which gives 186 minutes. So the total delay is 186 minutes. Have everybody got this answer? Any doubts? Now the second part of the question. Suppose if there are 8 cars in the caravan. The same problem, instead of 10 cars, can you solve with 8 cars and give the answer in minutes? Minutes or an hours, anything will do. Solve the same problem with 8 cars. Processing delay for 8 cars is how much? 8 cars. For each cars, it is 12 seconds. So 8 into 12, that's equal to? Yes, very good. 96 seconds. Nice. Okay, so now find out the propagation delay. Propagation delay is the same, right? 90 minutes. Now for 8 cars, it is 96 seconds. If it has to cross all the 3 toll booths, how much? If it has to cross all the 3 toll booth, what is the value? 96 into 3 into 96, right? So that is equal to, yes, 288 seconds. Which is equal to in minutes. Can you tell me in minutes? 288 seconds is equal to how many minutes? Very good. 4 minutes and 48 seconds. Now the propagation delay we have already calculated in the previous problem as 90 minutes. So what is the total delay now? What is the total delay? 94 minutes and 48 seconds. Sorry, not about 90. It has to cross 2 links, right? 180 plus. So it is going to be 184 minutes and 48 seconds. Because we have 2 links, it has to cross. So the answer is 184 minutes and 48 seconds. Okay, now we'll solve another problem. Can you take down this question? How long does it take to send a packet of length 1000 bytes to propagate over a link of distance 2500 kilometers with a speed of 2.5 into 10 power 8 meters per second with a transmission rate of 2 Mbps? Okay, so what all informations are given in the question? Can you tell me what all information is given in the question? Yes, give your answers. Okay, some of you have already calculated the answer. Very good. To help everybody, yes, the length of the packet is given. Packet length L is given as 1000 bytes. And the distance D is given as 2500 kilometers. Speed is given as 2.5 into 10 power 8 meter per second. And the transmission rate R is given as 2 Mbps speed. Now, So with this, what all delays can you calculate? Propagation delay and transmission delay. What is the formula for transmission delay? It is L by R, and for propagation delay, it is D by S. So if you calculate, how will you calculate now? So the total delay is L is 1000. Since it is given in bytes, and you can see that the transmission rate is given in bits, you have to change this bytes to bits. How do you change bytes to bits? How do you change bytes to bits? One byte is equal to how many bits, students? Yes, 8. Okay, so you have to multiply by 8. 1000 into 8. And what is the speed? 2 into 10 power 6. Okay, so which you will get as 4 divided by 10 power 3, which is nothing but 0.004 seconds. If you represent it as milliseconds, it is equal to 4 milliseconds. Okay, this is L by R. Now find out the D by S. D by S. What is the distance? 2500 kilometers. So 10 power 3 kilometers is 10 power 3. And then speed is 2.5 into 10 power 8 meters per second. Okay. So what is the answer you will get? Yes, you will get 1 by 100, which is equal to 10 milliseconds. So when you add these transmission delay and propagation delay, very good. You can see the answers. The answer is 14 milliseconds. So 10 plus 4, 14 milliseconds. So everybody have understood this problem? Any doubts in this? So there are a few more problems to solve, which I think we can share it. We'll share it in the GCR for you to solve since there is no time. Sir, shall I stop here for today?
Yes, ma'am. Yes, yes.
The remaining problems we'll share in the GCR. You can practice. Thank you.